So cut quickly, and then we can look at that. I will tell you what to do next, so that we see what comes out of this. So we have our net. We have our net there. Now can you try and make your solid? Can you try and make your solid? If you fold, I think it will give you easier time. Fold our net. Fold. Now if you're finished, you raise it up so that I see it. I see that you have done it. Make the solid out of it now. I see you have done what you're doing. Okay, now if you fold it, it gives us a what? A square base pyramid. And we said that we can get surface area of that pyramid by getting the base area and then the area of the triangles, the four of them. Are they equal?
Yes.
They are equal, isn't it?
Yes.
Yes. Now, I want you to cut. You have four triangles.
Yes.
I want you to cut. The triangles the same distance from this side. I want you to cut. Off that, this, that way, halfway. Yes, half of it. Cut half of it. So the height, the distance here, make sure you cut exactly halfway. Half of the height for the four triangles. Make sure you count the squares. Make sure you cut exactly at the I used the graph paper purposely so that you can be able to get the right place to cut it. Yes. Now as you cut, you'll tell me the shapes that now you end up with after cutting. Don't say it loud, just talk with your neighbor, your deskmate. Now, what shapes do you have now? You had triangles before and a square. Which shapes do you have now? What shapes do you have now? Let me just check on anyone whether they have the right thing. Whether they have the right thing. What shape do you have? What shapes do you have? We had a square and we had four triangles. Four triangles. Four triangles. Edit. What shapes do you have now?
The lower one is the faster. It's made up of a trapezium and square.
And square. So you're now having a pyramid that is cut off, isn't it? Yes. It has been cut off, and this is no longer a triangle. This is no longer a triangle, and this one is same, and that one. So if we look at these shapes, we have said that now we have one square there, a square, and we have a trapezium here, trapezium. Are they the same?
Yes.
Are they equal?
Yes.
They are all equal. So do we know how to get surface area of a trapezium?
Yes.
We know. How do we get the surface area of a trapezium? Surface area of trapezium.
I have AB
A plus B H. So if I'm to get the surface area of my first term, now this solid that now is being formed is called a first term. And if I'm to get surface area, I'll need to get the surface area of the trapezium, one of them. You have said they are all equal. So times 4. Then we add also the square. Are we together?
Yes.
So we can say that when we have a solid, I've carried some solids here. Here's my solid. I've carried a solid here. This one. Now if you look at it, you can see that a part of it, the upper part, if I was to extend this, I would have a square-based pyramid. Now, when I cut off a part of it, it becomes a frustum. So when you are having this, now if you look at this frustum, whatever you have made is an open frustum. It's missing a part of it. Can you see that? Yes. A part is missing, the upper part is missing. But if you get one which is closed, it means that you have another surface here. Which surface is this? This one. This one here. You had a square, isn't it? Yes. At the base here. Now again, there's going to be another square on top here. So you have to consider how to get this square. And the length of this square is not the same as this one. This one is smaller, isn't it? Yes. So it's smaller. So I have to look for a way in which I can get this one, this length here. And if I'm given this, and I'm told the length of the lower part and the length of this one, I'll just go straight and get the area. But if I'm not given, what would I use to do that? How would I get this length of the small one? That's a question to you. How do you get? How do you get? Let me just draw it here. Let me draw it on the board so that you can see what I'm talking about. Now, this was the triangle. This was the triangle.
Yes.
We know the length of this one. Now, from whatever you have done, you are going to from the graph, because I've used a graph paper, it's possible for you to get the length. Can you get the length?
Yes.
By counting the squares?
Yes.
You can. But what if it is just drawn for you like this, or you have been drawn for the pyramid in this form? This is your pyramid. Sorry, you have your pyramid there, and you have been told that this part has been cut off. The way we have cut, like this. This part has been cut off, and you remain with your frustum. How will you get this length? If you know the length of this one, let's say it is 10 centimeters here. You know this one is 10 because it's a square. And then here, you want to get the length of this one to here. How will you get it? Maybe you've been given the height. The height is here. You've been given the height of this one up to the top is let's say 15 centimeters. And you have been told to cut halfway, the way we did. We cut it halfway. So what is the height? What is the new height? What is the new height of this shape, the first one? 7.5. Because it is halfway, it's 7.5. So if this is 7.5, what is this length from here to here? You can tell me. You get a response here. Eh? 3. 2.5. She says it will be 2.5 from here to here. Do you agree? How? The question is how. How do you get 2.5?
I took 10 centimeters minus the height so that you can get the length of the smaller mini square.
Okay. Is that right? She has taken this one and subtracted 7.5. Are they on the same dimension? Are they on the same place? This I'm seeing is down here. This one is there. Eddie.
You say those two lines are similar.
Yes.
And you have been given the whole height is 15 centimeters and half of it is 7.5. So you say 15 over 7.5 is equals to 10 over x, that line which we have not been given, because multiply, even the line is 5 centimeters.
Now, she's talking of similarity. You know the similarity?
Yes.
Similarity. Now, we are told that anytime you have a figure, if you can get the ratio, there's a name we gave for that ratio. There's a name we gave that ratio. If you take the ratio of the longer length and you divide by the shorter one, what do you call that ratio? Linear scale factor. Linear scale factor. So in this case, if you have the height of the big one, which is 15, you divide by the shorter one, which is 7.5. This gives you a linear scale factor of 15 divided by 7.5. it is divide 2, it is 2, right? So in other words, even this line and this one, these two, they have to follow the same linear scale factor of 2. So if I don't know what this one is, let's call it x. If it is x, we have linear scale factor equals to the 10 divided by x, and we have been given the linear scale factor is 2. So 2 equals 10 over x. So our x will be equal to, it will be 5, isn't it? 10 divided by 2, which is 5. Okay? Now, we can extend this idea of frustum to other solids. Now, which solid is this? Which solid is this? Solid is this? Look at it. If I have a solid like this one, and it's a cone. This is a cone. Yes, this is a cone. And if I cut it at this point, I remove this upper part, I will remain with the frustum. Frustum over cone. And it will look like this, like that, look like this, like that, to look like that. If I cut off a part of it, to look like that. And we should be given, I mean, at times you'll be given radius of the whole cone, and then you're also given the radius of the small cone. Sometimes, I've not said all the time, sometimes you'll just be given one of them, and then you will determine this other one, so that you can be able to get the what? Surface area. Now, surface area, who can remind us what we said about surface area of a cone? How do you get surface area of a cone? Surface area of a cone. Surface area of a cone. Surface area of a cone. Participation from everyone. Yes. This surface area of a cone. The area of the base first. Area of the base is pi r squared. And what about the curved surface? Pi r l. And we remember that pi r l was L. What is L? Which line? Slant height. Slant. Surface area of cone. Slant height, this part, this one, it is slanting like this, right? So if I have my cone there, now what will be the, if I now cut off a part of it, what shapes will what am I going to now consider? We have, yes? We now, the slant height has changed. There's going to be a difference here. Yes? A difference. If I cut off like this, a part of it has gone up there and another has come, but it doesn't mean here. How do we do that? Yes? Can you think about it? Think about it. You have cut off a part of it. A part. Now, at the beginning, I got the surface area of the curved surface, isn't it? The whole of it. Can I now get the curved surface of the small one? I can, alright? But now I'll have to use the different radius for the two. And then, how do I remove now this part? I do what? I subtract. There we go. So we subtract that one. So that is the first terms that we have looked at. We also have this shape. If you are given a shape like this one, what we have learned can also be extended to this one. This is, I can give you the name of this shape. you there? What does this look like? How about you? The lower part. Okay. Look at trapezium. Yes. It's a hexagon. How many sides does it have? 6. 6. So it is
A hexagon.
And there? The shape now, the whole solid
Hexagonal prism.
hexagonal prism. Right? Yes. So I want to leave you with some work to do. In our books. Exercise 13.1. 13.1. Question number 7. Exercise 13.1. Question number 7, 8, and 9. So also I'll be marking. Can start with the first one. Check what you have been. Hope you're on there. You found the excess. A very simple one. A right pyramid on a square base, 8 meters, is 15 meters high. Find its surface area. Then the second part of it, you have a frustum. You're told how it is made. Let's finish the first part. Drawn. Okay, so we'll continue from there. I'll collect the books. I'll collect the books at the end of the day. Right?
Yes.
Yes. All right. Thank you for listening and have a good day.
Thank you.